Okay, hello, good morning. So this will be kind of a test because I'm not feeling that great. Um, I'm not sure. Well, I think I know what it is because from Friday to Saturday, I was joining a deploy. I didn't have to, but I wanted to because I had a quite a significant change and I wanted to feel confident that it worked. But it was like 2 hours in the evening just waiting. So I got to bed really late, like 12 or something. And then I just woke up at 2 a.m. Because it was like super windy outside. So I think it was a combination of that and me like being very restless. And then they were just about to start the deploy. So then I joined the deploy for 2 hours. So it was like 4 a.m. I got back to sleep. And then 6 a.m. our youngest wakes up. And doing a night like that, I can't take, like yesterday, I was completely out of it. But still today, like I feel dizzy and I can't like focus, like literally focus my eyes, which sucks. So I'm never gonna do that again. Like I used to be able to do that kind of stuff, but yeah. But like with all the stuff going on, like in everyday life, having kids, like you just can't. It takes longer to recover. I think that's the thing. Like when you're young, you can just completely, like even just the Saturday morning, right? I had to get up at 6 a.m. and I had to actually do stuff with our, I was alone with our youngest. And if I didn't have that responsibility, I would probably sleep in until like 12, 1 a.m., p.m. or something. Like just there, you would kind of recover most of it. But yeah. Um, Anyways, so I've been reflecting on the Bonsify thing, and I want to make it. I was thinking about like we were taking the perspective of building state trees, but what I've discovered refactoring the app is that these patterns aren't really specific to state trees. They are just fundamentally good patterns. And the only thing we're doing with Bonsify is allowing you to make parts, like make your objects reactive. So when you consume them in React, however you expose that object to React, it will optimally keep those components up to date or updated or in sync with whatever state is within that object. So what I wanted to do, like I wasn't sure, like had many rounds, but then I thought, okay, I think state tree should be just its own pattern. Like that's just a pattern of state management. You don't have to build state trees, right? So the way I'm approaching this now is that I'm stating that. Ooh, oh, what's happening here? There we go. By providing one single primitive reactive, that's weird. Reactive and a plugin that makes our components observers, Bonsify makes state management as simple as technically possible. Note that simple does not mean easy. And I think that's a huge confusion. Like sometimes we build abstractions and primitives with the intention of making things simpler. But what happens is that we just make it more easy. And easy it shouldn't be like the primary goal. Like if things are more like accessible, like it's not about this, like when I say easy, you can do something with less code, but it has consequences of doing that. I'm not sure if like I should put that here, but it was a brain fart, so I put it there. Yeah, I think I'm gonna do this as simple as technical. Oh, not simple. I am using the wrong word. Makes your components observers. Bonsify makes state management as simple as for React, as simple as technically possible. Making something simple is about giving you the free. Yeah, I like that better. So making something simple is about giving you the freedom to use the language to apply whatever encapsulation, constraints, and patterns you think fits your application. The only thing you really need from a library is to enable components to observe changes to state you expose to them. Exactly how you structure and expose that state does not have to be an opinion by the state management tool. After a decade of abstractions, primitives, and concepts. Oh, after a decade of abstraction, primitive, and concept overload, you might feel lost just using the language again. But do not fear, we'll get you going. And then there's like core patterns. And core patterns, it's about just constructing objects. Is it? I did oh, look at that. In my eye, it's reflecting the can I make this dark? Let's see. UI. Or how do I go to the extension? What's it called? Markdown. Does it have mermaid theme, preview theme? Oh, look at that. Atom dark. There we go. That's better. Well, it didn't look awesome, but okay. Is there another one we can rather use? Let's use GitHub Dark. Cool. Okay, so it's about constructing objects that hold state and behavior. This state needs to be reactive for components to be able to observe changes. So you can make any any object reactive. Consuming reactive objects and components makes them optimally reconcile when what they access from the object. Yeah, I'm kind of overstating this. This state needs to be reactive to be for components to allow components to make components needs to reconcile when the state they access changes. This is completely transparent. Transparent in Bonsify. Just make objects you expose to components reactive. You can make any object reactive. I'm also subscribing to this pattern now where you create a variable and then you point to the variable, because that's, at the end of the day, that's what scales. So there's less refactoring if you want to change your code. And then I'm calling it factories. Classes are great for constructing objects and organizing related state and behaviors. If you prefer using classes, please do, but the factory pattern gives you the same benefits with less keywords and concepts. And also, like, just creating a function instead of doing like an arrow function. Just do that from the start. It just scales more easily. Because if you inline stuff and you can't inline anymore, then you have to do like add brackets and do stuff. But if you just start doing this, then you have all the flexibility you need to make changes. So for example, now you can pass dependencies like that. You can also define private variables if you want to do that. And then you can separate behavior from state. And this is what I mean. It's like I could just move that thing down here now. I didn't have to refactor anything else. I could just move it because it still has the pointer to counter because it's just a normal function, not an inline arrow function. We can put it behind the return and all that stuff. So I think it's a good pattern. So this pattern is very useful as complexity increases. Think about everything before the return as a constructor of a class and everything after as the methods of a class. But unlike a class, there is no this reference. You just point directly to any dependencies, variables, or functions you want to use. And then nesting and composing. This is really where I want to add a new document. So state trees. State trees. So we're going to move nesting and composing. And also passing. Well, let's put that in there. So passing a parent reference is not necessarily tied to state trees. Yeah, how are we going to do this? Well, yeah, let's keep it here. But I want to, when nesting state, pass the parent reference. This can be achieved by, let's close that one. Oh, interesting. It doesn't work very well. Let's see. So nesting and composing, separating objects and factories. Yeah, separating factories and composing them back together makes your code more readable, increases your reusability, and improves testability. You can compose by simply create counter, and then let's change this to function create state. Const state, return state. What the hell is this? Goppels? Interesting. By the way, I saw Claude 3.7 was released. I'm not sure if I have it here, but yeah, I would love to try it. Yeah, and the point here is that now you have like a very specific counter. It can be in its own file, increasing like discovery. That's readable part, and then it increases reusability, which isn't that important, but it does. So you can have multiple counters. And testability. Like if I exported this create counter, I could just test that in isolation if I wanted to do that. So when nesting, I don't want to call it state here, because this is the thing I'm not completely sure of, because I have a feeling I want to kind of do this even without having reactive. Because it's not really about reactive. Reactive is just like, it's just the interface between your actual components. Yeah, I'm not sure about that separation. But yeah, let's keep it here for now. So let's see. Where were we? Passing parent. When nesting objects, it can be useful to pass the parent reference. This can be achieved by using a getter. Also attaching the parent reference to the nested state. So this I want to remove, because attaching the parent to the actual state exposed to components is about like components. Yeah, so I feel like a state tree is more about the interface with components. It's not about state management. So it's almost like you can create these different factories for different pieces of state. And some of it might be like just wrapping Firebase. Some of it might be like doing session handling. Like, it doesn't matter. It can be just different things. And then as you're going to expose these two components, you compose them together in a way that makes it optimally consumable by components. That's how I think about it now. Because as I mentioned, refactoring the other app, I just noticed like even that Firebase abstraction, like it could just expose the data as reactive. It didn't have to like be. That didn't have to happen like in the state tree itself. Yeah, and even the authentication. Because it's just as testable, right? Like we're just calling reactive around an object. It's still the same object. It's just if something is observing it, that observer will react to those changes, but it's still normal changes. Yeah, it's very interesting. Let's see. When nesting objects, it can be useful to pass the... Yeah, so am I using... It's about constructing objects that hold state and behavior. Yeah. This is completely transparent in Bonsify. Just make objects you expose. Well, we don't have to even say components. Just make like it's about it's about creating an interface, right? State management is about creating an interface. So when we say like a component, you can implement state in the component, that's not an interface. You're literally just putting the state inside the component. There's like no interface between like the value and setting the value and the component, right? You just have like set state and state. But creating an interface means like it actually has a meaning. So you have a counter, and then instead of just set count, you have increase, for example. That's what I mean about creating an interface. And that's what we're doing here. We're actually defining state and behaviors Components needs to reconcile. Yeah, state management at its core is about creating an interface to consume state and behaviors. With React, this interface needs to be reactive. So any state accessed by a component will cause the component to reconcile when changed. So any changes to state accessed by a component will cause the component to reconcile. State management at its core is about creating an interface to consume state. Okay. Bonsify enables this reactivity. I completely understand if you find it super boring, but this is what I like. I like to find ways of communicating and like structuring, like what are we trying to do? I find that very rewarding for some weird reason. With React, this interface needs to be reactive. So any changes to state access by a component will cause a component to reconcile. Yeah, so this so Bonsify enables this reactivity. Reactive state management. You can make any object interface. You can make any interface reactive. Yeah, you know what? We're not gonna even have this thing. We're just gonna have counter. Here showing, well, this is kind of the, no, I can do that. You can make any interface reactive. Here showing a counter. Showing a simple counter. And classes are great for constructing objects and blah, 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 but the factory pattern gives you the same benefits with less keywords and concepts. Blah, 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 blah. Okay, I think that's what I wanted to. Think about everything. Okay, and then when nesting, pass the parent reference. This can be achieved by using a getter. Okay, but we're not gonna like attach it here because that might be confusing. Like I want to, that's part of the state tree thing. So instead of consuming state, we're gonna do exposing state. And then I think state trees are going to be actually part of that. Derive in JavaScript state in objects using getter, blah, blah, blah. This is fine. Using getters. Disposing, you might initialize state that creates a side effect that needs to be disposed of when you later remove the state, blah, blah, blah. So let's just make counter undefined here just to be like super clear. Effects and let's just do this instead. Blah, blah, blah. Defaulting to strong guarantees and typically slows down. For example, to create an action, dispatch it, and then resolve an immediate blah, blah, blah. This encapsulates the state and gives some guarantees, but it slows it down. With Bonsify, we'd rather subscribe to an open and accessible model where you as a developer and team create guarantees encapsulation where it makes sense. So, yeah, that's fine. The promises part, I want to move that to data fetching. Okay. And then we're going to rename this to... So we have core patterns, but then we have explicit states. So I want to add some more. We have explicit states. We have it's data fetching. No, I think those should be, so let's rename these to rename 3 and then rename, because this is like not, yeah, I'm not sure how this is going to look, but 4, and then we have rename. Yeah, and then context, I don't think, yeah, I guess context is also about exposing state. And I think we can move context in there. Because I don't think that's the point. Like now I had this like very strong separation between passing in a context and building a state tree, but it's just factories, right? The factories in the context are exactly the same as the factories building up the state tree. It's just a pattern. And there's no reason why you cannot, like, so for example, with the Firebase thing, I created the Firebase as part of a context on the outside and then pass it into the state tree. But I might just as well just pass the config of Firebase into my state tree and then create the Firebase thing there. Yeah. So explicit states, unions, algebraic data types, or finite state machine. The concepts are very similar. The idea is that you define state that reflects being in different explicit states. So instead of writing session blah, 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 you describe more correctly the specific states the session can be in and what functionality and what behavior is available in each state. So session authenticated, you actually have a user, you can sign out. If you're unauthenticated, don't have a user and you can sign in, or you're authenticating where you can't do anything. This has several benefits. The explicit state is a string that describes that the actual state. With TypeScript, you can narrow down what values are available in each state, and you can exhaust what states. You can narrow down what values are available. In each state, and you can exhaust what states are available. Okay, you can guarantee that certain logic, that certain behaviors is only run in certain states. Normally, a finite state machine is implemented with a dispatcher type of concept. That means you can ask it to do anything at any point in time, but its internal implementation guards the execution by checking the current state. The bad side to this is that you will never know from a consumption perspective what functionality belongs to what state. Okay, so I don't think we actually need to comment this. It should be self-explanatory. So here we create a counter whose state is idle, and then we remove start and stop. Yeah, this is fucking beautiful. Let's see, const state. I'm just gonna use the same pattern everywhere to just show the consistency here. Okay, so this is great. So this is just, these are core patterns, and then you have explicit states, which is more like any of these you will kind of encounter or have questions about. And then you have these other things, and then data fetching is... Data is also state. The difference between data and regular state is that we need to asynchronously fetch the initial state, and making changes to that state needs to be synced. Oh my god, that was fetch it. Yeah, making changes to that state needs to be synced with the server, often referred to as server mutations. There are primarily 3 different strategies to manage this. So you have local mutations, fetch data once, and rather manually apply local mutations to the data, where server mutations is a background process. So let's go in and just refactor these as well. So that will be backend. In this type of data handling, what I think it's losing now is like, just how does all of this come together? Because now it's like we're describing it in parts, and then it's like, well, how does it look like at the end of the day? In this type of data handling, you can just toggle the complete the state of any to-do, push new to-dos on the existing data array, etc. Create app. Yeah, create data app. Yeah, revalidate on mutations. Refetch data after a server mutation is performed. What the hell am I writing here? Refetch data after a server mutation is performed. Refetch data after a server mutation is performed. This type of approach gives a strong guarantee that whenever the client requests a server mutation with what is actually on the server, this will so the point is that all the references are gone. Well, I think I'm writing something. Okay. Revalidating data typically causes all references. Yeah, so this is the thing that's like, I think references is like, where are you at with your experience in programming in general, but also JavaScript? And how does that, and what's your level in React in terms of understanding how references actually affects reconciliation in React? So the point there is that whenever you do revalidation on mutation, you'll get a completely new list and a completely new set of to-dos, even though they represent the same data. Like, the references are completely new, and React will reconcile any component referencing any piece of data. Revalidating data typically causes all references to typically expires all existing references to the data. What does that mean? Like, I don't know how to put that in a very short, consistent. Okay, let's just write that for now, and then let's say function create data. Function create app. Subscribe to data and get updates automatically. This type of approach simplifies data fetching and server mutations, as we only interact with the server. There is no manual intermediate step to keep data in sync. And again, let's just change the example. Function create app. And I'm gonna change create app to create state. We're gonna search for that. Oh, this is actual data, but this is state. State. To not confuse that with, like, I want to hold off this idea of the state tree thing until we actually get there. Yeah, and then data references. When you fetch a list of to-dos, the array of those to-dos and each to-do has a reference. In the world of React, those references... Okay, I think I'm gonna drop that comment because we are talking about it down here. In the world of React, those references matter because it is what memo components use to determine if the component needs to reconcile. The pattern of mapping an array and render nested memo components is the most common optimization in React. If you use a revalidation approach to data fetching, it means that the to-dos arrays and each to-do in that array will change reference whenever you request any changes to the array or any item in the array. In other words, your to-dos list component and every to-do component will reconcile regardless of any change and using of any change. Using memo has no effect. Like, you can argue if the list has some other, has no effect, has little to no effect, because you might argue that the list maybe toggles something that reconciles the list, and then if the data hasn't changed, like you have validated, that will yeah, I am gonna drop that one because it depends. Normally this is no concern as reconciliation is fast, but if you're displaying a lot of to-dos where each to-do has a complex UI, you risk performance issues. Local mutation strategy is what best optimizes references and therefore reconciliation. After that, automatic sync, where you subscribe to specific changes in the data, also best optimizes references and therefore reconciliation. Make sure you reflect on how your data fetching affects your data references and the reconciliation of components. It can be a good idea to default to revalidate on mutations, but optimize with local mutation or change subscription if available. In this example above, we are exposing data directly to components, but you might want to rather derive data to some state management at expose. What I kind of like about the documentation of Bonsify is that we're actually talking about the actual nature of state and references, as opposed to like, oh, this is an atom. It makes it so easy to make a change. Because this is the stuff you really have to learn, not like, oh, what's the best primitive for observation or for making components reconcile whenever they change. Anyways, in the examples above, we are exposing data directly to components, but you might want to rather derive data to some state management that exposes the data in a more controlled way. So again, we have, and then const to do, turn to do. I love that prettier formats. So state. Now we're hiding data from the components and gain control of how components interact with it. This is actually pretty cool, but it's like, I wouldn't do this for like a solo project. There's no reason to do it because you have full control of how you actually manipulate your data. But in larger teams and projects, I think this is a good idea to basically protect the data so it doesn't change all over the place. Deriving data references. If our data fetching ensures the integrity of data references, we break that integrity when deriving. Export function, create state. Return state. Const state. Cool. So what we mean here is that even if our data to do's ensures consistent references, our map and create to do will always create a new array and new state objects in that array. To make sure the create to do state object is only created when the underlying to do data reference actually changes, comma, we can use a reference cache. Let us see it in action. Again, changing here. Const to do, return to do, oh. And then create state, state. When calling create cache to do, it will first check if the data reference is in the weak map. If so, it returns the existing state. If not, it creates the state as normal and caches it. Using a weak map is perfect because we don't have to clean up the cache. When the data reference is no longer available, the state removes itself. Yeah, and then we have promises. Like, this is not really specific to data fetching. Like, a promise can be anything. Yeah. Anyways, the mental model for promises is often that they act as a temporary primitive that transfers a value from an asynchronous source from an asynchronous source to a variable like this. But promises does not disappear when it is resolved. The promise is the value. So you can also say like async data promise. So you can get that value whenever you want. You can hold on to the promise and retrieve the value whenever you want. So for example, we can have a promise of a counter and make it reactive. Ooh, create state. Const state. Return state. Oh, what did I do? Oh, function. And I guess fetch counter. Yep. In the component, you just do state counter. Yeah, so I think we can make this a pattern of its own. But what we should rather talk about here is no, I don't think we should talk about promises. You can choose to put promises into your state. Yeah, I kind of, these are like patterns, but exposing state, well, I guess exposing state is also a pattern. Two components. Two components. So I wonder if this should actually be number 3. Yeah, I think so. This should be number 3. And then we can make this one number 5. Okay, so Bonsify makes observation transparent. With the include bubble SWC plugin, any component function defined in your codebase will become observers. That means you don't have to think about adding observation or worry about props passing, etc. The observation memory footprint is tiny and saves you from a lot of reconciliation work, as components will only reconcile by the state they observe. Additionally, these observing components uses memo, as your props passing will mostly be with state references, which are non-changing references. Okay, so first we need to talk about when you're creating these state management nodes, or like it's basically just objects, right? And you choose exactly how you wanna structure this. So there's no like, how should I put it? There's no rules about like, or I guess what I'm pointing to is this context concept. Like some of it is context, some of it is not context. It's the same thing. It doesn't really matter. What matters is what you actually expose to your components. That's what matters. And the thing is that what you expose to components, that's what needs to be reactive. So that's why I don't like core patterns to even talk about reactivity. But at the same time, it has to do that. Okay, so how should we put this? Creating the interface. Oh, and this can be confused. Creating the state creating the state interface, or What do I mean to say here? Like the point is that if your app is a counter, like you just wanna give the counter. Like there's nothing special. And then you might wanna. The thing that's tricky is like you can't create state in React reliably. Like you can't have a component that calls one of these factories, because if that factory has a side effect, you can't reliably dispose of that side effect because of concurrent mode, which is a confusing aspect in and of itself. Yeah, maybe it's okay to start with this. Creating a contract between state and components. With state management solutions, you often consume root state through a context provider and use selectors to narrow down to a specific state you want to consume. Problems arises if you use TypeScript and your state is at some level dynamic. A value or branch can be there. Okay. Or a value can be there or it might not be there. For example, a component might want access to a user, but the user might be null. If the user is passed as a prop, it is guaranteed it will be there. But if it is consumed by a selector hook, you cannot give that same guarantee. That is why you should not consume state directly or using a context provider. Pass it down as props. Yeah, I think this is, as your components narrows down on specific state, also pass the related narrow state down as props. Your components can always reference back up the state tree, no matter how. Yeah, so here we can put attaching parent state. So it's almost like I want, maybe what I'm trying to do is making a state tree completely implicit here. Just by the fact that you're like creating this state and passing it down, that just intuitively, like, what is this state? And it might be a complete state tree, or it might be something very simple. It's just you. Maybe a better way to explain this is like you want a single point of reference. That's what you really want. Whatever that single point of reference is, if it's a single object with some values, whatever it is, because you don't want to have like multiple props and pass down like many different props. That's the thing you want to avoid. So I think that's, yeah, a single point of reference. When exposing state to components, yeah, that's what I want. At least maybe this is not written in the best way, but that's really what I want to convey. It's like you want to have this single root object that you pass from the top of your component tree as a prop. That's how you should do it, because then any component can explore the state they're looking at. And here we can also write about attaching the parent state. So you can traverse back up the state tree or the state objects. When exposing state to components, it is a good idea to expose it with a single root reference. Since Bonsify This reduces the complexity of props passing. Less props passing, more discoverability. By traversing state through a single object. Optimal reconciliation. Well, I guess that's not true. Single root reference. When exposing state to components, it is a good idea to expose it with a single root reference. Pass this root reference as a prop, which we're going to explain later. Yeah, maybe we should call it. No, maybe that's obvious. Creating a contract with state management solutions, you often consume root state through a context. Maybe it's obvious. Pass it down as a prop. As your components narrows down on specific state, also pass the related narrow state down as a prop. This reduces props passing and maximizes discoverability. Props passing and maximize discoverability by finding any state pointing to the state object. Traversing up can always if a component has been passed a nested state as a prop, it can be if a component has been passed a nested state as prop, it is useful for that component to still be able to access parent state. This can be solved when you construct your state phase. Parent. It's just so create nested. Oh, look at this. We even found a mistake. Oh, where is it? let's just call this create state. So let's do this. Get nested or get counter. Return counter, and this would be state. Counter. Create nested state. State. Counter. There we go. So we're creating some state, and we're going to give a counter. So this would be state. Let create root. Create root. 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 And root. Root. And this will be count. Increase will be counter dot count plus plus, and this will be the counter, or yeah, sorry, this should be create counter. Create counter. Okay. Notice how we passed the root reference down to a counter and also attached it on the counter object. Now a component consuming only the counter can still traverse back up. Let's just add a root title, awesome app. Or let's just call it is awesome. Oops. Is awesome true. So in a component, you have like tsx counter, and you're actually getting the counter state here, right? And you're gonna do something button on click counter. Well, I guess you can just say counter dot increase, and then yeah, that's another benefit of not using the this keyword. It's like you can just reference like this, which is nice. Count is counter dot count, and then and then counter dot root dot is awesome. Awesome. Or no. So the point with this is that when you're exposing state, you can attach, in this case, we're attaching the root state to the counter. So then if a component is just consuming the counter, it can still point back up the state tree and find stuff there. And this just works with observation and everything. Okay. Yeah, I don't think I'm getting the point across here. I'm not sure. But maybe when we get to the point where we actually have a reference app, maybe it will make more sense. And then exposing state to components. And then we have data fetching. We have explicit states, which is nice. We have promises, and then we don't actually need context. Let's delete that. One thing I wanted to talk about was Let's see. Yeah, so this is promises. And another thing is like this concept of consuming mutations, which is very fascinating. But that could be put into data fetching, and we should really like, well, I guess with the app we're refactoring, it doesn't really matter. Because we're just changing Firebase and it's so fast that there's no need to have like a pending mutation state. But it's kind of cool. It's a cool pattern. And basically what it is that when you do a mutation on the server, what you do first is that you add a state called like changing title or mutating title or something. And then components can actually consume that state to detect that you're in a pending state, and that pending state can also hold the data you passed. Yeah, and hold the data you pass to the server so you can show things optimistically. And then if it errors, it still stays there. Like that piece of state stays there, but it goes to an error state, and you can show the error, and you can like more easily retry because you still have that mutation state. Like it's a very cool concept. But yeah, let's not go into that now. I think this is fine. We're gonna update this, and then we're gonna take these learnings, and then we're gonna refactor the app a bit more. Can I just go to main and merge it? Git merge new docs. Yeah. Something like that. Yeah. Okay, cool. Sorry, this was maybe a boring stream, but yeah. Thoughts and reflections. Bye for now.